Okay, these ones are going to be, again, more solving equations based off some stuff like this. So you're going to see, first of all, something like this. The ln of 5x plus 2 equals the ln of x plus 10. Now, when you have two ln's equal to each other, or for that matter, two logs that are equal to each other, as long as the bases are the same, then everything else should be the same with them. The equal sign is pretty powerful. It means they should be identical. If they're not identical, then we got to make them. So what's going to happen for this particular thing? When you see, change both of those, please. When you see this is the equal sign, then that means this side should equal this side. Well, right now, if you look at matching, I match ln for ln. So that matches. Now the next thing that needs to match is this stuff. Does this match this? Well, that's what we're going to set equal to each other. So for that particular thing, if you want to get rid of the ln, if you e both sides, all you get is 5x plus 2 equals x plus 10. The equal sign is pretty powerful. As long as the bases are the same, then the other stuff should be equal to each other. Okay. So, for example, or to finish out this problem, how do I solve for x? Subtract 2. Subtract x. What's 5x minus 1x? 4x. Deuces go away. X's go away. What's 10 minus 2? 8. Now what? Divide by 4 and x equals 2. Awesome. Done. Now, a couple things that's going to happen, and they don't really talk about it necessarily in this particular concept, but later on, if any of you go on to take college algebra, it's going to also go on to say, now check for extraneous solutions, meaning this. We're going to get answers, and I don't think you guys are going to have any of these today, but later on in your college algebra classes, if you put 2 back in there and it gives you the log of a negative number, you can't do that. Okay? Because when you graphed logs, did anybody notice there it went from where the range was from 0 to infinity? When you graphed a log, it went like this, right? And this was the x like that. Meaning the domain starts at 0 and goes this way. So if you try to put a negative in there, it's going to give you an error. Okay? Non-real answer. So that's something that you would have to check at that time. Your textbook does not talk about that. So therefore, probably not going to see it. All right? What do you think of those? Pretty easy? Good. ln of 4x minus 7 equals the ln of x plus 5. What do I do? Okay, so make it 4x minus 7 equals x plus 5. What happened to the ln's? You can either e them, which means if you e them, then they cancel each other out. Or because if you know that an ln equals an ln, then the other pieces should also be equal to each other. So how do I solve it? Subtract x and add 7. I get 3x equals 12. Divide by 3 and x equals 4. What do you guys think? Not too bad? Awesome. Now, the next part. What if they're not log on both sides? Bum, bum, bum. Okay? If you don't have log on both sides like this, then what I'm going to do is I'm going to rewrite this as an exponential problem. Do you remember when we rewrote that for the first test? All it was rewriting it from a log to an exponential or exponential to a log. This is in log form, so I want you to write it as an exponential. What is the base number? 2. Raised to the what power? Nope, not 5x minus 17. 3 equals 5x minus 17. Remember, this one's the base number. This is the exponent. And this is what it's equal to. What's 2 to the third? 8. Equals 5x minus 17. Can you guys solve for x? Add 17, I think I heard somebody mumble. What's 8 plus 17? 25. Equals 5x divided by 5. And what is 25 divided by 5? 5. Log base 3, 10x minus 9 equals 4. Okay, hold on. Got it? Awesome. Okay, so does it have log on both sides? No. So once it doesn't have log on both sides, I want you to rewrite it as an exponential. What's the base number?
3.
3. What's the exponent number? 4. What should it equal? 10x minus 9. Okay, now, here's where most people mess this up. 3 to the 4th is not 12. 3 to the 4th is 81. That's an 8 and a 1. Now, how do I keep going and solving for x? Add 9. What's 81 plus 9? 90 equals 10x. Divide by 10. 90 divided by 10 is 9. Done. What do you guys think so far? Not too terrible? Awesome. Okay, this one now, this is probably the harder ones that you're gonna see today are ones like this that say log 2x plus log x minus 5 equals 2. Now, first of all, we need to write it like we did the last problems, but the big but in this problem is there's 2 logs and not 1. So, what's adding the same as when it comes to logs? Multiplying. So what I'm going to do is I'm going to condense it into 2x times x minus 5 equals 2. So I used those properties or the laws that we had a couple days ago, and I rewrote it as a condensed log. Okay? Everybody okay with that so far? Adding was the same as multiplying. What was subtraction the same as? Division. Awesome. Now, once you get it as a log of blah equals blah, now rewrite it like we just did the last problem. What's the base if there isn't one listed? 10. So 10 to the second equals, all right, well, might as well just multiply that out. 2x squared minus 10x. I distributed. What is 10 squared? 100 equals 2x squared minus 10x. Now, you guys have had this many, many times. You've had quadratics before. What's a quadratic again? How did I know that's a quadratic?
Squared.
It's x squared, right? In order to solve a quadratic, what are some of the ways we have? Quadratic formula?
Square root.
Complete the square. Factor. Graph.
Square root.
What do you want to do? Now, here's what I'm going to suggest, or here's what I'm going to say about this thing. they're not going to make you spend a whole lot of time dealing with the quadratic formula. They're not going to make it so that it's that hard for you. It's not their goal to make these more complicated. It's the goal to using the logs in order to solve. So, I'm going to say 99% of the time these are going to factor. Okay? So just so that you guys know, factoring is faster than the other ones, especially if you don't have all the proper materials. Either way, you got to make it equal to 0 first, which means subtract 100. So I get 2x squared minus 10x minus 100. Then, does anybody notice I can take any number out? I can take a 2 out of everyone. If I take a 2 out, that's the same as just dividing everything by 2. What's 2x squared divided by 2? Yay. What's negative 10x divided by 2? Nice. What's negative 100 divided by 2? Negative 50. Woohoo! Okay, now as far as factoring goes, what times what gives me x squared? X and x. What times what gives me negative 50, but adds up to be negative 5? Negative 10, positive 5. If I were to solve those, and by solving them I mean put them each equal to 0. X minus 10 equals 0, gives me x equals 10. X plus 5 equals 0, so therefore x equals negative 5. Now, I have a problem with one of those. And this is why it doesn't really talk about it in the book a whole lot. There is an issue with one of your answers. What did I just tell you couldn't have? Can't have logs of negative numbers. Not the answer that you get is negative, but if you plug it back in, is it a log of a negative? So if I put 10 back into here and here, 2 times 10, is that number okay? 2 times 10 is 20. 10 minus 5, is that number okay? Sure. Now put negative 5 in there. Uh-oh, we got an issue. 2 times negative 5 is negative 10. You got to throw it away. It becomes what they call extraneous solution. Okay, that number should not exist in my answer set. What do you think if I were to cross out both of them? What would my answer be?
No solution.
Good, no solution. And will that happen? Could. Now here's the bad part. You go through all that work, you need to find it that it's no solution. Okay? But my only answer for that should be the number 10. Okay? Let's see here. Let's go. Oh, they're all adding. Boo.
That's on your recording now.
I don't care. Okay, same type of problem. Too many logs. Okay, you gotta drop one off. So, how do I get rid of the adding? Multiply them. Remember, adding is the same as multiplying. So I have log of base 6. Now, quick question. Do you want to multiply it all through now or do it later?
No.
You want to do it now? What's 6x times x?
6x squared.
And what's 6x times negative 1? Now, one little side note. Do you know why I put it in parentheses still? What, Kylie?
He's probably doing this. We have something to do.
If I didn't put this in parentheses right here, then if I was an outside reader looking at it, it would look like the negative 6x would not be a part of the log. That's why I did it. So you're right on the right track. Now, did I drop a log off? Sure. How do I rewrite that now? Huh? 6 squared equals 6x squared minus 6x. What's 6 squared? 36. Equals 6x squared minus 6x. Again, quadratic. What do you got to do? Subtract 36, so get everything to one side versus the other. Is there a number I can divide everything by? 6. And if I divide everything by 6, what do I get? X squared minus x minus 6. What times what gives me negative 6, but adds up to be negative 1? Negative 3 and positive 2. And when I set them each equal to 0, I would get 3 and I would get negative 2. Do they work?
3 does.
Why?
It's positive.
Because it's positive, and when I plug it back in, I get positive numbers.
Yep.
What if it's positive and I plug it in and I still get negative numbers? Is that an issue? Yeah. If you ever plug it in and you get a negative answer, that one needs to go away. But this one stays and that one goes bye-bye. And again, you put negative 2 right there, that's negative 12. It's done. Okay? What do you think? Not too bad? Okay? So, starting on page 338 and going to 339, 21 to 39, multiples of 3, and 43. Again, just to remind you, you start at 21, then 24, then 27, and so on. Up to 39, then stop. And go to 43.